So, this guy up here by the restaurant is looking down to this guy up here on this observation deck. This angle that he's looking down is angle 1. And I wish they would have just put angle 1 further over here so you know it's in here. But how far he's looking down is angle 1. Angle 1 right here is called an angle of depression. An angle of depression because he's looking down. Okay? Depression. This dude, if he looks up at the guy at the restaurant, he's looking up. So angle 2 is right here. It's called an angle of elevation. Now, going way back to chapter 3 last semester, okay? What do we know about angle 1 and angle 2 if these two are horizontal lines, which means they're parallel lines? What do we know about this angle and this angle? They're congruent. Why? Because they're blank, blank, blank. Alternate interior angles. These two angles are alternate interior angles. So your angle of elevation looking up at something is going to be the exact same thing as your angle of depression looking down at something. So if this dude here is checking out this fly girl down here, okay, angle 3 is called an angle of depression. And if she's here checking out him up there, this angle 4 is an angle of elevation. So you have to know the difference between an angle of depression and an angle of elevation. And we'll get to that in a couple problems. No, he's not looking at them at the same time. He's looking up and then down. Okay. When I was in Florida a couple summers ago, I actually saw one of these on the beach. Kind of cool. So it's like a bungee. They throw somebody up in the air and they bounce up and down and up and down and up and down. Kind of cool. So it's called a reverse bungee ride. So Reagan stands halfway in between two posts. Two bungee cords from the top of the posts are tied to her waist, which is 1 meter above the ground. How tall is the post from here to the ground? Okay, from there to the ground. Well, what I would do is not try to use a picture, but I would draw my own triangle here, okay, and then get the information from the triangle. So I know this is a 70-degree angle here. If this is a vertical post, what other angle do I know? If this says it's a vertical post, what other angle do I know? Well, I know this angle is a 90-degree angle, right? Because the ground we assume is horizontal. So if we assume the ground is horizontal and the post is vertical, then we have a 90-degree angle. Then trig is really easy for this, okay? Because if these two posts are 8 meters apart and the person's halfway in between, how far is the person from the post? How far is this side of the triangle? 4. And we need to figure out x. Okay? How do I figure out x if it's a right triangle? Ooh, formula sheet. It's on your formula sheet. We don't have to do law of sines or law of cosines for this. It's really easy. It's a SOHCAHTOA problem, right? What is this and this? What's this from the 70? Opposite. 4 is adjacent. Opposite adjacent is tangent. So the tangent of our 70-degree angle is our opposite side over our adjacent side. What do I have to do to solve this? Multiply by 4. Somebody take 4 times the tangent of 70 on your calculator.
11.
11.0. So this is 11.0 on this side. So x is 11.0, but that's not the answer to the question. It said, how tall is the vertical post? So it's 11 from here to here, but it's an extra meter from there to there. On the test next week, there'll be problems like this where something is a little above the ground, so you'll have to add that distance onto whatever you get when you do your trig. So if you add the 1 and 11, how tall are the posts? 12 meters tall. They're more like 37 feet. So, all right. Next one. Nadim sees a tour bus from the top of tower. So she's standing up here on the top of a tower, looking down. She is her eyes are 180 feet above the ground. Okay. How far is the bus away from the top of that tower where her eyes are at, looking down? Okay. So if her eyes are 180 feet above the ground, the angle of depression is 23 degrees down to the bus. What's this angle over here? How big is this angle right here? 23 degrees, because the angle of depression is the same as the angle of elevation. So I have opposite. We want to know how adjacent is. Opposite and adjacent is tangent. So the tangent of our 23-degree angle is the opposite side 180 over the adjacent side of x. Now let's remember from the first part of the chapter, how do you get x alone if x is in the denominator? What's the next step to solve this? Do we divide by x or multiply by x? Multiply by x. Got to get x out of the denominator, so we multiply by x. They cancel. X tangent of 23 equals 180. And then how do I get x alone? Divide by the tangent of 23. How far is the bus away from that tower? A long ways, I bet. Over 180. What's 180 divided by the tangent of 23? What'd you get? 424, basically, feet away. Okay, 424 feet away. So in this section, you'll have problems where you're solving kind of word problems. And then what you'll also have is figuring out things like this, like how big is this angle right here? Angle ABC. This angle right here. Well, let's take and break apart this triangle a little bit. A is up here, C is here, B is here. Now, if this side of the triangle is 20 and this side of the triangle is 20, how far is C from the edge? Because C is in the center. If the whole side is 20, how far is C from the edge? 10. It's 10 from the edge. And if this whole side's 20, each part of this triangle is 10. So how long is BC? Well, if this is 10 and this is 10, how long is this? Well, on your formula sheet, you have an isosceles triangle called the 45-45-90 triangle, right? If each of these are 10, how long is this? 10 square root of 2. So the length of BC right here is 10 square root of 2. Now, AC, they give to us right here. That's 20. And we want this angle. Well, I know my what here? Opposite. And this is the adjacent, which is what trig function is opposite adjacent? So the tangent of angle B equals 20 divided by 10 square root of 2. Now, this is where you have to be really careful. This is where you have to be really careful with your calculator. You have to go 20 divided by 10, press equals, and then you have to go again divided by the square root of 2 and press equals again. Okay, so you get some decimal. So the tangent of B equals, what's our decimal? 0 point something, something, something. Wait, no, it's 1 point something. 1.41, yada, 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 right? So to get b alone, we have to take the tangent to the other side, correct? So it becomes the what tangent? Inverse tangent. So you go second tangent of second answer. Second tangent, second answer. You figure out what our angle is. What is our angle? 54.7 degrees. Okay. So most of this is a little bit of review from what we've done this chapter. This is the only new thing. Finding the area. Get out your formula sheet. If it's not out yet, get it out. At the bottom of your formula sheet, it says something about area of a triangle. Okay? There should be 3 area formulas on there. Area equals 1/2 BC sine of A, area equals 1/2 AC sine of B, and area equals 1/2 AB sine of C. What angle do they give us here? 28, so it's A is 28. If we have side angle side, 2 sides surrounding an angle, okay, then I can figure this out. So area equals, since I have angle A, I'll go 1/2 BC sine of A. I'll use that formula because A is the angle I have. So my area equals 1/2. B is 25. C is 21 sine of 28. You plug it into your calculator, it spits out the area to you. What'd you get for an area? 500 and something? 400 something? 600 something?
123.
What did I do wrong? Oh! Ooh. Yeah, I suppose. 123 point. Somewhere in there. Okay? That's how to find the area. If you're wasting marker, young lady. Oh, okay. Then that's fine. Go ahead, waste away your marker then. Okay. So if you're given A, it's this formula. If you're given B and you have these 2 sides, okay, use the B formula, the sine of B formula, and so on. That's how to find area. Okay? And that's all I have for you. So I will assign out your Savas. So you have a Savas to do, and you have to finish this Savas up, and that's it for today. Then when we come back next Wednesday, we'll review for the law of cosines, take that quiz, and then review for the test. Yep. Yes.